Good evening. I have a confession to make. When we started the Mentoring Talks initiative in 2016, I did not envision we will have the chance to host a Nobel Laureate to give a mentoring talk. Thank you, Sir Fraser, for honoring us with this. Good mentoring is crucial to shape up students' goals, and as such, it substantially increases the students' chance to succeed in their academic journey. With it, students learn to develop the essential skills to overcome the hurdles and challenges they face, to take impactful decisions, and to develop approaches to face any obstacles. Academic advising is about creating new opportunities, shedding light on new paths, impacting career choice, and expanding horizons. To continue our initiative of mentoring by prominent speakers, I am truly thrilled to host the 2016 Chemistry Nobel Laureate, Sir Fraser Stoddart, for today's mentoring talk. Presently, Sir Fraser is a Board of Trustees Professor of Chemistry at Northwestern University, having previously been the Sol Winstein Professor of Chemistry at UCLA. He was honored by Her Majesty Queen Elizabeth II as a Knight Bachelor in her 2007 New Year's Honors List for his services to chemistry and molecular nanotechnology. Sir Fraser received the 2016 Nobel Prize in Chemistry, along with Professor Ben Feringa and Professor Jean-Pierre Sauvage for the design and synthesis of molecular machines. The title of Sir Fraser's talk is Research Excellence Through Innovation, Doing Your Own Thing. Sir Fraser, the floor is yours.
Thank you. Well, good afternoon, and thank you all for coming. Thank you. I'm really having a wonderful time in this little country called Lebanon. I had the great good fortune to plant a cedar tree this morning, and this took me back to my roots on the farm, and that's where my mentoring talk is going to begin today. So, it might be useful if we can reduce the lights on the stage, not entirely, but just a little bit, because what you see here is the home in which I was brought up. It is the farmhouse of a tenant farm. That is, we didn't own the farm, we didn't own the land. It was merely rented from one of the lords of the day, Lord Rosebery, and as such, we had to pay a rent every 6 months, which meant that we had to create some wealth from this family activity, and I think that, to some extent, left its mark on me, because, you know, after we are talking about World War II. My parents took me there in 1942, which was in the middle of that war. After the war, Britain went very much towards being a communist culture, and so ultimately I was to meet up on a daily basis at school and then at university with young people who had been rather indoctrinated with no matter what you did in life, you couldn't fail because the government would look after you from the cradle to the grave. I did not have that experience. I had the experience of we had to make ends meet, and more than make ends meet in order to pay the rent. This was my bedroom window. And from there, but before we leave that, this is the part at the front of what a so-called walled garden. And so in these parts of the world, where you don't have the nice climatic conditions that you have. Most of the homes that are sizable in any way have this walled garden, and so this is usually facing south. It captures the sun, what sun it gets, and the walls warm up, and you can have fruit trees against them. I think this was an apple tree. Ultimately, in particularly my teenage years, I would spend a huge amount of time just growing potatoes and peas and cabbages and cauliflowers, and there was automatically rhubarb and fruit trees. Apart from the apple and the peach trees, there were soft fruits like strawberries and raspberries and black currants and blackberries and red berries and so forth. It was just a haven of lovely things to eat. And remember, this is at a time when most of the populace in the country were having to get by on rations. And so out of this bedroom window, this was part of the view of the so-called farmsteading. And so starting just behind my father here with his sheepdog, that was the dairy. This was the so-called wash house where the dairy utensils were washed up every day. This was the source of the hot water. There was a boiler in this boiler room. And here, rather antiquated, is a horse trough. And this was the coal house where the coal was used to fire the boiler. And then this was the stable. And then as we went in this direction, this is where all the cows were kept and the byres. And so it was in this area here that I was able to strip apart cars and tractors and so forth, which you could do in these days because they were so fundamental. And you had to do it because their engines would coke up and they would become very inefficient. Instead of firing on 4 cylinders, they would maybe be down to 2 cylinders. And it was really absolutely essential that you decoke them. And so, to some extent, in this area here, I began life as an engineer. Now, before I got to that stage, of course, I was just a little boy playing around. There weren't very many other children because we only had 2 cottages. Sometimes there were families in them, sometimes there weren't. That used to change quite a lot. And then you could go for a mile in any direction before you would meet any other habitation. And we did not have electricity on the farm until I was 18. So again, I was brought up without this modern convenience that we're all rather familiar with. And of course, as I grew up and went to school in Edinburgh, I was the only kid that was coming from a home that didn't have electricity. Right, so I call this Edgelot Farm the University of Life. So to summarize a little bit about that early period, here I am with my parents. I guess I'm about 3 or 4 there. I'm probably about 17 here, and this is an Ayrshire bull. I was an only child, but I had highly supportive parents, and they sacrificed an enormous amount for my schooling. And this has been, and I hope it continues to be, a huge tradition in Scotland. The Scottish people know that they're probably not going to, if they have children, have them turn out to be smart and they stay in the country. They will probably leave and go to some other part of the world. And as I said, there was no electricity until I was 18, and the nature of the farm was a mixed arable farm, which meant that we grew oats, barley, wheat, turnips, swades, kale, potatoes, and hay. And in terms of the other stock, we had cows, of course. We had sheep, and my mother looked after a lot of hens. We did not have pigs. My father did not like pigs. So the point about my young life was that we were really free to run wild in an incredibly open way. The door just opened and you could go out and do what you wanted. So we had to invent games because There wasn't anything sort of laid on. There was no television or anything like that. And risk-taking amongst we young people was highly encouraged. We would effectively stoke each other up to the extent of, can you do something that's more daring than me? And to that extent, it's really almost amazing that we all came out of it alive. And of course, as I got older, hard work intervened, as it had to do with dairy. But there was a lot of reward for effort, and that reward was good food and companionship and so forth. So, first of all, I went to a village school for 4 or 5 years. I think I went when I was 4, so that must have been in late 1946. And this was a one-teacher, one-room school. And my mother related to me in later life, but I was only allowed to go for half a day on the first day that I went. And when she picked me up by car, I apparently said, I'd had such a wonderful time, could I stay all day the next day? And so I got immediately engaged in the educational process at this Carrington village school. But come 1950, my parents felt that I should have a more uplifting education. So I went to this college, Melville College, for the next 10 years. And that provided me with a great general education and absolutely terrific teachers. And just 50-50 men and women. It was a great piece of diversity before its time. And these men and women could easily have been professors at a university. They were so knowledgeable, and they put a huge amount of emphasis, when I look back into it, into mentoring. And so I'll say that there was the so-called Duke of Edinburgh's Award, which allowed members of the school to go on expeditions for whole weeks up in the hills and the mountains of Scotland. But I will focus in on what I remember that I cherished most, and that was the fact that a man called Lord Harwood started the Edinburgh International Festival while I was at the school. And this opened up the city to orchestras from all over the world, like the Berlin Philharmonic or you name it, with composers of conductors of international repute, but also composers. I had the opportunity to actually meet with Shostakovich, and at the other end of the spectrum, people like Maria Callas and Marlene Dietrich. So it was just a mind-blowing experience, and the teachers encouraged all of this. They arranged for us to go to these concerts and so forth. We wore ridiculously red with a little bit of black trim uniforms. Sports were emphasized, so here you see, this is me, in the hockey 11, and there was also a cadet force. So on a Friday afternoon, we had this sort of army training at a low level. What did we learn in terms of academic subjects? Latin, French, English language literature, history, geography, mathematics, physics and chemistry, and also a bit of philosophy. And at the end of that period, which meant I was 18, I went to Edinburgh University, and here I spent the next 7 years, and it is over 300 years old, the chemistry department. This is the so-called James Black building, or Joseph Black. He was the member of the so-called Scottish Enlightenment that included people like the philosopher David Hume, the economist Adam Smith, an architect Adams, and an engineer James Watt, and also poet Robert Burns. And these were very clever people who interacted with the founding fathers in the United States on a very regular basis, and also with the people in Paris who were leading the French Revolution. So I had my bachelor's degree in '64, and since I started my research in '63, and the story there was, and I'm probably repeating myself from the talk I gave yesterday sometime, I got this opportunity to start as a result of lecturer in analytical chemistry, quantitative style, boasting that his 10-week course had been running for 10 years and nobody had ever finished it. And so what I was able to do was finish it in 7 weeks as a result of just multitasking, which was, of course, something I had learned on the farm. In farm life, at least at that time, you could be doing almost 6 different jobs at once, if not at once, one after the other. And brought me the opportunity to get into a research lab for the first time in the summer of 1963. And I've never looked back. I've just become addicted to being in that kind of environment. And what were we researching? And I want the young people to note that this is a dramatically different field from the one that I will talk about at the end that took me to Stockholm. We were researching the composition of gum arabic. Yeah. Oh, you're always very kind, Sarah, as always. Thank you. And this was the small research group. I'm here on the right. And there were no women, I'm sad to say, but we were looked after to some extent by this man, Douglas Anderson. He was not all that committed to research, I have to say, or to mentoring. He kept very small hours. We would see him maybe about 10 or 11, and he would have disappeared by 3 in the afternoon. So even during my PhD, I had to be pretty independent. But this independence got a big fillip when I left to go to Canada in the February of 1967. And this marvelous man, who didn't have any research students of his own, this was an era when the professors, and he was the professor of organic chemistry at Edinburgh at that time, did not have students. They had lots of people, including this man, Dougie Anderson, underneath him. But he, of course, welcomed us at the end of our time and gave us some advice. And so when I last saw him, he said to me, as I went to Canada, whatever you do, Stoddart, identify a big problem. And so I head off to Queen's University, Kingston, Ontario. This is at a time when aeroplanes were just coming on the scene. So this is the first time that I got on an airplane at the age of 25, and arrived in this place that was bitterly cold on the 1st of March. Here is the research group that I was part of, and this is Ken Jones. Now, Ken Jones intimated within a day of me getting there that he was going to Brazil. No, not for 2 weeks, but for a whole year. And the fact that the Canadian Postal Service went on strike for that year meant that we had no communication at all with Ken Jones. Walter Zarek here had been brought back from Rutgers University, an ex-student of Jones, to look after the group. And I should parenthetically say that Walter has just turned 80, and a few weeks ago I was back at Queen's giving the first Walter Zarek lecture. But it was the good fortune of being able to go to the library in the middle of April of that year that opened my eyes to the fact that there was this man that I'd never heard of, Charles Pedersen, who published a paper describing the synthesis of dibenzo 18-6. So this is a macrocycle with 18 atoms in it, 12 carbons, 6 oxygens, and he made this at least in a 50% yield, courtesy of a templating of the potassium ion, which was present in the reaction mixture. Here it is in this form here, and this is a molecular model of it where you have the potassium there, and the oxygens are pointing in towards that potassium ion. Otherwise, they would be water molecules. So this is a nice piece of pre-organized complexation of a potassium ion, and it was this template that allowed him to make the molecule in the first place. And this flew in the face of all the teaching that I had at Edinburgh, where I'd been told you can make rings that are 5, 6, and 7 in size, but forget about the big ones. Well, this was a game changer, and I should say Pedersen was, of course, to become a Nobel Laureate in his own right in 1987. And so I started playing around with big rings, and being typically Fraser, if Pedersen could make them with 18, here was me making them with 30 and 35 atoms in the ring, very easily from carbohydrates, alpha-cyclodextrin and beta-cyclodextrin in a 3-step synthesis. And at the end of that period, I ended up also taking the courageous step of writing a book on stereochemistry of carbohydrates. And I say a courageous step because if I had not met up with this man here, Ernest Eliel, and sent my manuscript to him to be as it were, vetted, I would probably have ended up with a shameful existence of publishing a book that everybody would find so many mistakes in. And so he, as it were, saved my skin, and it was published ultimately in 1971. The book, I started writing it at Queen's University, and I think of the 5 chapters that it is, 4 were written there, and the last one was completed when I went back to the UK, to Sheffield, in 1970, and the book was subsequently published in 1971. So the book was finished at Sheffield. As I say, this was my first example of American academic of very high stature who embraced me as a young person and really mentored me in a way that I can only feel a lot of warmth towards. And that continued and through until the time he passed away. But on the local scene, I was faced with a situation where there were 4 professors who were at war with each other. It was not a pretty sight. They did not agree that their subject was, or put it another way, they only accepted that their subject was worthy of intellectual pursuit and poured scorn and derision on what the other professors were doing. So it was a really bad introduction, if you like, into mentorship in the subject itself. And the professor of organic chemistry, I eventually worked out, was hugely resentful of what I was doing, and so made my life extremely difficult. I didn't see my first graduate student to join my group until 1972, and the whole existence in the early 70s was very stressful. The teaching was, of course, challenging because I was just beginning it, but I did manage to get some research underway. And that research involved going back to these crown ether rings, so you've got 18 rings here with 6 oxygens, and they've been married to carbohydrates. So we have either glucose or mannose or whatever different type of carbohydrate that is readily available to marry to these crown ethers, which makes them so-called chiral, which means that they can show enantioselective behavior on complexation. And at the end of this period, I was able to write a nice Chemical Society review describing that work. But this will show you how much I was addicted to chemistry, because this is a beach in Edinburgh where you will see Portobello Beach. This is my elder daughter, Fiona. I guess she was about 6, yes, and my younger daughter, who would be 3 or 4 at that time, Alison. And you can see the pattern of these sandcastles. This is the 18 crown 6, The blue bucket is the potassium ion here, and these pebbles are the electrostatic interactions that are holding it together. And on the left-hand side here, you see the sugar. The one place I was defeated in was I couldn't show the stereochemistry of the sugar. And so coming back to this review in 1979, you'll see some of my passion for chemistry coming out with this first quote in the early first paragraph. I had been in Canada when Robert Kennedy was assassinated in 1968. He was trying to run for the presidency and was shot down in a hotel in Los Angeles. But he had been going around the country using some lines that come from George Bernard Shaw that I find very uplifting. Some men see things as they are and say why. I dream things that never were and say why not. And that's really what you have got to have as a couple of lines guiding you if you're going to be a creative person in any field. Some men see things as they are and say why. I dream things that never were and say why not. And taking these dreams forward in chemistry, here's the Nobel Laureate from 1975, the majestic Vladimir Prelog. And I quote him because he emphasizes the importance of creativity in chemistry. Chemistry takes a unique position amongst the natural sciences, for it deals not only with materials from natural sources, but creates the major part of its objects by synthesis. In this respect, the potential of its creativity is terrifying. And so here you have in this field of chemistry, which is about primarily making before you measure and you model or whatever else, making is the important thing. And so you are just in the same league as a painter or a sculptor or a composer or a novelist. You have this opportunity to express your creativity in making. And so to take up this theme, here is a book that I refer to by an author whose name I can't pronounce. All I can say is he's at the University of Chicago, which is close by, about flow and the psychology of discovery and invention. And I have a few quotes to share with you in the audience. Creative persons all love what they do. It's not the hope of achieving fame or making money that drives them. Rather, it's the opportunity to enjoy, to do the work that they enjoy. Curiosity and drive are in many ways the yin and yang that need to be combined in order to achieve something new. And there's two components to creativity that he points out that I agree with. The first requires openness to outside stimuli. The second, inner focus. The first is very playful. The second is rather serious. The first deals with objects and ideas for their own sake. The second is competitive and achievement-oriented. Both are required for creativity to be expressed. And so to sum that up, you have to go through this sort of playful period where you're tossing about crazy ideas in your mind. And then if you do get something that could be a game changer, it's not going to be a game changer unless you show it over and over again to be important. The right milieu is important in more ways than one. It can affect the production of novelty as well as its acceptance. Therefore, it's not surprising that creative individuals tend to gravitate to our centers of vital activity where work has the chance of succeeding. Now, in the early part of the 20th century, a lot of the famous painters, including people like Picasso, descended on Paris. But not just painters, novelists, sculptors. It was just a hotbed of creativity in the arts and the humanities. The great centers of learning and commerce have always acted as magnets for ambitious individuals who wanted to leave their mark on the culture. And so I guess you could think of places like Silicon Valley in modern times. Creativity, this is very important, I think, for many professions, and particularly for chemistry, is rarely the product of a single moment. Perhaps more often it is the result of a lifetime. And I'm an example of the lifetime enactment if I have been creative. Creative individuals usually are forced to invent the jobs they will be doing all through their lives. Creative individuals don't have careers, they create them. Okay, so maybe the last thing that I will add that is not in the quote says that it's not easy to be creative. At some stage when your creativity is beginning to be expressed, you generally have to face some criticism and some, as it were, detractions from your work. So I found a lot of inspiration came from the culture of the Celtic culture, which is contained here, and on the side you see some intervention from Chinese culture. But this is probably present in Arab culture as well. We have the Book of Kells, and we have all these interlocked and interlaced structures on tombstones and so forth. In everyday life, we have bicycles, we have chains, we've knots, more chains, scissors, rings, lots of chains, nuts and bolts, and nets. And here is my eldest grandson. He's now 14. He was roughly 6 months old. And what is he holding? He's holding a dumbbell with 3 rings on it, and his hand, if I count all of these, he's holding a 5 retaxian. And so, as a very young kid, you are already playing with mechanically interlocked entities. Interlocking in fashion, belts, shoes, ties, rings, watches. And here is my only granddaughter, Kate, and she's wearing what the Americans call a onesie. And this particular garment, unless you have some poppers at the back, is very near impossible to take off. And so this was an inspiration to us and one of my graduate students to make a mechanically interlocked molecule that was based on the onesie principle. And we called them soutanes. And here is a space-filling representation of a crystal structure where the red component is the onesie and the blue and yellow components are the, as it were, equivalent of Kate's body. This is it dumbed down even more. How was it obtained? It was obtained, again, using these crown ether rings, 2 of these, to come on and bind with these ammonium centers, and then to have some paraphenylene diamine present that would form 4 imine bonds. And this chemistry is such that 5 components can be brought together under what's called thermodynamic control, pushed along by hydrogen bonding templation and the formation of these reversible imine bonds. And it's often referred to as DCC, or dynamic covalent chemistry. And the reason it's brought together is there's all these interactions, just as there were for Pedersen's simpler situation, that are being picked up during the synthesis here, and they're, of course, expressed in the final product. So, what is a mechanical bond? Well, the best examples are, and the ones that people know best of all, are catenanes, interlocked rings, 2 minimally, or a dumbbell and 1 ring for a retaxane. And I call them mechanically interlocked molecules. Wikipedia get it right. They are molecules based on the Latin rota for wheel and axis for axle. Also, the derivation of a catenane comes from Latin catena for chain. So again, molecular species. Now, one of the things that I've said all through my career, there are no firsts in science, and there's probably no firsts in any walk of life. We're always building on the shoulders of giants before us. And one of the giants in this area was a German, Gottfried Schill. And in the 1960s, he used very roundabout ways to produce 2 interlocked rings. This is called directed covalent synthesis. So he used classical chemical bonds to build 2 rings that, became 2 rings that were separated from each other after he broke the chemical bonds. And these were over 20-step synthesis. And there is the picture of him about the time that he was doing this work in Freiburg. And he published a book in 1971, in the same year as I published my own book that described catenanes, retaxanes, and knots. Now, what I've got to share with you here is this is a great example in Europe, and it's not uncommon, sadly, in more modern times in the last 50 years, where you have a very inventive person, and like myself, he was not supported by his colleagues and his professors. But maybe, unfortunately, not like myself, he didn't fight back. He eventually threw the towel in. If they had supported this person appropriately, he could well have been part of the team that went to Stockholm. So the support of your colleagues and so forth is an important part of the mentorship process. So back to the science, going back to molecules means that when we get to these mechanically interlocked molecules, we got there by using these weaker forces that are described as molecular recognition, self-assembly, and ultimately template direction. And so you start off with something like this, where you have molecular recognition, but they are two components. This is not a molecule, this is a complex. But then as soon as you put two stoppers in that are bigger than the diameter of the inner diameter of the ring, then you have a molecule. And if you take the sort of purple-blue rod here and put it into a ring, then you have a catenane. Okay, so back to my life story. So Sheffield was the time when we married crown ethers with carbohydrates, as I showed you in that review, and also it forced me to be incredibly imaginative, just as I had to be when I was on the farm, which was the University of Life. Resources were kept away from me, and so I had to get by with little. But then again, I was blessed by meeting another great American scientist in 1976 in New York, Donald Tram. And he turned out to be immensely supportive. He lived his whole professional life at the University of California, Los Angeles, UCLA. And I wasn't to know, of course, way back in 1976, that I would end up going there to be his successor in 1997, some 20-odd years later. So in the beginning, he made it possible for me to spend 3 months at UCLA at the beginning of 1978, and he knew that my life was not short of being a miserable one in Sheffield, so he arranged for the Science Research Council, wrote very powerful referees reports, and ICI to support me to go on a 3-year secondment to ICI's corporate laboratory in Runcorn. So this was the laboratory I went to in 1978. The family moved across from Sheffield and lived in an old Roman city called Chester, which is a lovely city. And for me, it was a complete breath of fresh air. It was full of talented scientists who wanted to collaborate with each other, young scientists. It was extremely well equipped. And as I say, collaboration was the order of the day. I joined a group called the Catalysis Group, had about 70 members, and I met a man called Howard Colquhoun that I'll introduce you to in a minute. And together with him, we took up the discovery and invention of second sphere coordination. And this also led to us using both diquat and paraquat, which were two of the wipe-out weed killers that ICI were marketing about that time. And the other person that was a key pin in our collaboration was a absolutely amazing X-ray crystallographer at Imperial College London. And he is another example of being in a chemistry department where his colleagues did not support him well. And so just about a year ago, when I was asked if I wanted to speak at the opening of a new chemistry department for Imperial College, I said, on one condition, that you bring back David Williams from retirement in New Zealand to share the platform with me. I will make them belatedly honor this man. The other thing that was important about my time at Imperial Chemical Industries was I instinctively learned much more about the management of research. So here is diquat and here is paraquat, these two wipe-out weed killers. They kill a wide range of grasses and broadleaf weeds. At least they're off the market now, but in 24 hours, green would go to brown and crumple up. They're very fast-acting, and they're rain fast within minutes of application. So even if it rains after they've been applied, it doesn't matter. And they're inactivated upon contact with the soil. And so the second sphere coordination was a birth out of the work of Swiss chemist Alfred Werner, who was himself a Nobel Laureate in 1913 for so-called first sphere coordination. And so what he did was to take transition metals and close them with organic ligands. Very, very transformative type of research. And his, if you like, disciple in the UK was Joe Chatt, who spent quite a part of his research period with ICI. And one of the people, this is Howard Colquhoun, that he mentored in a sense was Howard, and left him lots of samples of first sphere coordination complexes for David Williams and Howard and I to work on with this graduate student and establish the field of second sphere coordination. And here's just a couple of sentences or three from Joseph Chatt in one of his reviews about the whole act of discovery in science. Scientific discovery is not yet predictable. If you have an exciting road to follow, do not be put off by those who say there's nothing at the end of it. They do not know. Persevere and enjoy the excitement of exploring the unknown. Okay, so the unknown to us was, here is the transition metal complex, one of dozens that we looked at, that is now being encircled in a half horseshoe-like manner by dibenzo 30 crown 10. So just a bigger variety of Peterson's DB 18C6. And when we saw that we had this nice interaction as a one-to-one complex, it was very obvious, being with the company, that diquat would obviously stand a good chance of sitting in there as well, and it did. And so this opened up the donor-acceptor chemistry that led to many of the major advances subsequently. Now, at the same time as, a couple of years after I left ICI, and I should maybe parenthetically say it had been my intention to stay in the company. I had had enough of this academic life with lecturers and professors who were not collaborating but were fighting with each other. But I was faced with the fact that the ICI corporate lab by 1981 was ready to be closed down. And so I had no option but to go back to Sheffield. Before I go back to that story, here is just some chemistry I'm not going to go through from my co-laureate Jean-Pierre Sauvage in Strasbourg. The point I want to make here is that it was published in 1983 in tetrahedron letters, and in this day and age when metrics are also important, the impact factor of this journal is very small. But it illustrates it doesn't matter where you publish a piece of work, and it doesn't matter in what language you publish it. It was published in French, and it was a Nobel Prize-winning paper. So at the beginning of this year, you see Jean-Pierre, he's been already invited to the University of Freiburg, and he's speaking about the work of Gottfried Schill. And this is Schill and his wife. They're now in their early 90s, sitting there on the second row. And afterwards, you see them conversing in German. Jean-Pierre has some fluency in German. And he sent me these slides just to share with anybody this sort of emotional moment of the coming together of two world leaders, one who was forgotten by his department and one who got a Nobel Prize. Okay, so I returned to Sheffield in '81. Little had changed in the department, but I was that bit older, that bit wiser, able to handle the situation with growing confidence. And I made some very dramatic changes in my life. I had been the little boy from Scotland, from a farm. I'd been very quiet and taken all the things that were going on around me without any comment or criticism. But on return, I decided it wouldn't be so much about trying to sort the situation out locally. I decided, Fraser, start writing to the Times of London, to the Manchester Guardian, and to the Telegraph, and tell the people what they're not hearing, because there was a lot of bleating in British science about this time about lack of funding. And I said, no, it's not about lack of money. It's about the corruption in the system. It's the fact that it's being misused or not used at all. So I became very unpopular, to put it mildly. The next thing that made me hugely unpopular, and just think of Brexit as I say all this, I was confronted with these students who had been brought up in a pseudo-communist system that didn't feel they had to work all that hard. They felt that they had been born with a silver spoon in their mouth. And so it would be good to amble into the research laboratory at 9:30, go to the coffee lounge for coffee at 10, spend 40 minutes there, come back, spend a few minutes in the lab, and then go back and have an hour and a half lunch break in the same place, a few more minutes in the afternoon before they would go back for tea, and they would have disappeared by 5 o'clock so they could go to the pubs at night and have a great time. Well, that's fine, but we weren't pushing the research agenda forward. And so I thought, okay, I'll bring in some foreign students. So students came from Italy and Spain and France and Germany, and it was totally transformative. Within a very short period of time, all this socializing on the scale that I've described to you stopped because these incomers weren't interested in this style of living. And so this happened, I think, on a big scale in the UK. The country was turned around, not just in academia, but elsewhere, by the influx of people, first of all, from Europe and then from other parts of the world. And the clowns that are in charge of the country now want to reverse all that. Well, they're in for a surprise. I found supporters beyond the UK, particularly in the US. Research thrived, and it set the stage for the making of mechanically interlocked molecules. And yesterday I described the synthesis of the first catenane in '89. My wife and I ran at least teens of conferences with the graduate students and the postdocs, invited the great and good of the day to Sheffield and then ultimately to Birmingham. But I was ready to leave Sheffield in 1990 and went to Birmingham as a result of being headhunted by the then Vice Chancellor, Sir Michael Thompson, a physicist. And he put a big investment into a laboratory. It was called the Hallworth Building because this was the person who had won a Nobel Prize in Birmingham back in 1937 for his synthesis of vitamin C. However, coming back to myself, I'm finally a professor touching 50. I have excellent students. Now, from this year on, never less than about 15 different nationalities. We have brand new laboratories, state-of-the-art equipment. Research blossoms. The molecular shuttle comes on the scene in '91, the molecular switch in '94, and a 5-catenane we called Olympiadine in '96. And I also take on the leading of the School of Chemistry as its head for 4 years. One can just say change was dynamic. But through all of that, there was a dark cloud on the horizon, because in 1992, not long after I went to Birmingham, my wife was diagnosed with breast cancer. And she had surgery in 92, a lumpectomy. That did not, as it were, address the problem, even with chemotherapy and radiotherapy, and so it was followed with a mastectomy in 94. And during this time, I was being headhunted by UCLA. My wife was not very keen on going to America, because we had 2 daughters who were still either finishing their school education or starting their university education. But come 1997, it seemed to be that we should go there, and we did. And this was, again, a huge change at age 55. I just had to face up to the fact that I was an assistant professor going into another academic system. It was quite foreign to the one that I was leaving in the UK. And it was a big hill that I had to climb, steep learning curve. But this time, I had very supportive colleagues. I remember the day that the now 90-year-old Fred Hawthorne, eminent inorganic chemist at UCLA at that time, within days of me arriving, was on the phone saying, "We must go to the faculty club for lunch." And I accepted his invitation, and when we sat down, he said to me, "Fraser, what can I do to help you?" I just about fell off my chair. It was the first time a senior professor had said anything like that to me. So a very, very different dynamic. We had collaborations. They were very, very many. And I became director of the California Nanosystems Institute. And so it was a very highly productive period in research in molecular electronics and in drug delivery systems using our molecular switches. One with Jim Heath and the other with Jeff Zink. And traveling went up a lot. It's nothing to the point where it is today, but it was quite considerable. And then after this 12-year period, my wife died in 2004. And so for a third of our married lives, we were fighting this insidious disease together. It was a fifth of her life. And quite a remarkable woman she was. So as I say, the science was related to drug delivery systems and molecular electronics. So here she is. And I don't want you to get the wrong impression. She wasn't the greatest supporter of Fraser Stoddart. She was much, much brighter than me. In the Edinburgh system, she was the top first in chemistry. I was the top second. My 2 daughters eventually acquired top first degrees from Imperial College London and Cambridge. So I'm really the dunce of the family, okay? And so she wouldn't hold back in terms of her admonishments. It's well seen you were brought up on a farm. This is her commenting about some of my habits. We can't go anywhere to eat, but you get your food all over you. And then the ultimate, I sometimes wonder why I married you. That slide has a way far too much information on it. She was a biochemist. I would get rid of most of it. 90% of what you have there is redundant. So you can see, at all levels, it was criticism. What would she have said today? I can only leave you to guess. All right, so I'm getting quite thirsty, and at this stage I want to share with you a piece of music that covered the first 65 years of my life that was put together by some of my great graduate students at UCLA. So, yes sir, no sir. this was in the wake of being knighted. And what you're going to hear is Sir Paul McCartney singing When I'm 64. Thank you. You all relax. Good stage. Live, I can't say very much. Well, I've had a little practice. Hmm? No. Thank you for the invitation. Is it really 10 past 6? Yeah. Wow. I've got another hour to go.
What country is that?
Hmm? Wait to see. We're only halfway through. Okay. Yeah.
Every summer we can rent a cottage in the middle of winter.
So in the June of 2007, having received a phone call from the British Consul General in Los Angeles on the 13th of November 2006 that led to, Tony Blair, the Prime Minister at the time, has it in his mind to recommend to the Queen in England that I be knighted. And I was rather shocked. While I was still suffering from shock, he said, I've got to know now whether you will accept it or not. And so my whole life went before me. I had not been what one might call a royalist in my youth. However, I was persuaded to accept. And I got in touch with my two daughters and got both of them within minutes. One was in Boston and the other was in Cambridge. And they were rather nonplussed, but they came back within an hour, jumping up and down, because they'd clearly done some research and realized that this was maybe significant. Anyway, we all went to Buckingham Palace on a date in June, and the Lord Chamberlain says, "May I present Your Majesty Professor Fraser Stoddart for services to chemistry in nanotology." Wow. She's got this very sharp knife on my shoulder, and I'm kneeling before her, and I'm in a cold sweat. And I get up, and as sharp as anything, she says, "He got that wrong, didn't he?" Yeah? And I always said, "He certainly did, Your Majesty." What should it be then? Nanotechnology, she answered it herself. It's about very small things, isn't it? And so I mumbled something about being 100,000 times smaller than the diameter of human hair. And she said, "That's exceedingly small." And again, she'd done her homework. "You work in America now, I'm told." And I said, "That's so," and I was on my merry way. That was my 15 seconds of meeting with Queen Elizabeth. Quite a remarkable woman. Okay, and so now we move to Northwestern, where again, I have terrific students, great colleagues, and support, because 2007 was the year of the gongs, as we Brits call them, awards. And so one of them was the King Faisal International Prize in Science. So that takes me to the King Abdul City for Science and Technology in Riyadh, and get a lot of support for my research from there on. We publish prolifically, many invited lectures. A couple of startup companies are launched. I am on the honors committee promoting honors to students and faculty at Northwestern, and I become a fellow of the American Academy of Arts and Sciences, and ultimately, when I become an American citizen, of the National Academy of Sciences. And we come up with a second book, and I spoke about this yesterday, so I just mentioned that it was published in between hearing about the Nobel Prize on the 5th of October in 2016 and going to Stockholm in December or 10th of that year. This was on the 7th of November. So, as I've said yesterday, it was a 6-chapter book, and the person who did most of the heavy lifting was Carson Bruns. So, let's just look at excellence in our work in academia. The state or quality of excelling or being exceptionally good is a definition of excellence. Extreme merit, if we bring it down to just simple words, superiority, an action, characteristic, feature in which a person excels. The level of excellence in research in the fullness of time, defined ultimately by the breadth of its consequences, and of a discovery of an invention that is a consequence of all this activity, be it scientific or technological, or indeed anything else. Dual nature of research. It can be incremental, which means that the research formulated with the conceptual framework is of long standing. It just is one thing built after another, based on hypotheses, theories, and practices. Transformative research is of a more challenging type. It challenges long-standing hypotheses, theories, and practices. And so the differences between the two are that transformative research is revolutionary, whereas incremental research could be described as evolutionary. Further differences between the two. What constitutes the main difference between the two kinds of research is the degree of personal freedom to choose a topic rather than the problem formulated being applied or basic or targeted or blue sky. And so that's back to what I was saying yesterday, namely, it should be left to people to decide what to do research in, not to governments saying we should be doing this project or that project. They don't know. Two kinds of thinking. Deductive thinking, which is intellectually challenging, with more than likely an incremental outcome, or inductive thinking, which is more intellectually challenging and with more than likely a transformative outcome. Drivers of excellence in research. Good recruitment and career backgrounds, internationally competitive recruitment and career opportunities should be at the top of the agenda for academic leaders in choosing their colleagues and their students at universities and other research institutions. Granting agencies, they should focus on generous funding of people, often young, with novel ideas as the main criteria of funding. More risk-taking gives better payoff when it comes to real breakthroughs in research, supporting people. And collaboration is also important. Collaborations in research within universities and across institutions at both national and international levels leads to the best outcomes in research. 90% of my research has been published with other scientists. Okay, drivers of excellence. This is rather funny, actually, and it's from a PhD thesis of a social scientist at Lund University. So he has worked out that a Nobel Laureate has had, on the average, 7.4 other Nobel Laureates during his or her career that he's been in, or she has been in contact with. On the average, a Nobel Laureate has worked in 4.6 universities, institutes, before receiving a Nobel Prize. In other words, it's good to move. The environment, I conclude here, seems to be contagious. Fostering breakthrough research. This is a document published by the Royal Swedish Academy of Sciences in December of 2012. Reports the highlights and better support of individuals with new ideas is one of the highlights. Better career opportunities for young students, more focus on international recruitment, good academic leadership to build creative research environments, and concludes money is not the issue. And I support that all the way through because I got off the ground without lots of money. Facilitating major discoveries, diversity is important, communication and integration, enlightened leadership, organizational flexibility, and responsiveness to changing events around you, and a great readiness to break rules. I have broken rules like no tomorrow, even to the point of almost being fired from institutions. And here's some advice from the 2009 Nobel Prize winner in chemistry, Venka Ramakrishnan, at the molecular biology laboratory in Cambridge. There were two other important lessons I learned at the Laboratory of Molecular Biology at Cambridge. I found that almost nobody there was working on routine problems just because they would lead to publishable results. Rather, they were trying to ask the most interesting questions in their field and then developing ways to address them. The other lesson was that even very famous scientists would ask questions at seminars that were often trivial to people in the field. It reinforced in me the feeling that ignorance is not something to be ashamed of, and that no question is too stupid to ask if you want to know the answer. So, doing your own thing. This is an article that I published in Nature Nanotechnology. and is half my title today, to achieve something that is impactful in contemporary science and to be singled out as a scientist who leaves their mark on science and ultimately technologies, you need to become recognized widely as having done your own thing. And what do I mean by that? This goal means that you make a conscious decision. It has to be a conscious decision to sum up enough courage to tackle a big problem for which no one has provided a satisfactory answer, scientific or otherwise. Tackle a big problem. So now let me just quickly tell you what I'm doing post-Nobel. So this young man, well, he's almost 50, has just moved from St Andrews to join me at Northwestern, and he's going to be quite independent, and he is going to work in what we call our research palace on systems chemistry. He's looking out for postdocs and graduate students. So if there's any of you in the audience wants to have a great experience with it, I predict a future Nobel Laureate. Get in touch with Doug. I have a lab in China that I've been allowed to, or I've been invited by Jay Siegel, who is the Dean of Science at Tianjin University. And two of my graduate students, Texican, Mark Olson and Andrew Su, are part of that setup. And Andrew is writing up the Chinese version of our book on the nature of the mechanical bond with these two young ladies. Future professors at the University of New South Wales are this ex-postdoc, a battery man, so energy, Dongjun Kim, or we just call him DJ for short, and Albert Fahrenbach, who was very much trained under the wing of Ali Trebosi that I spoke about yesterday. Another brilliant graduate student, starting off, both of them as assistant professors. Here's my shocking footprint for 2017, where I traveled over 330,000 miles, air miles, visited 5 continents, 15 countries, 42 cities, and gave 65 talks. And as you see, it's spattered all around the world. Let's speed it up. This year, we're probably going to cover more air miles. And so far, the red shows you where I've got to, although we're not quite up to date. As you'll see in a minute, we've already been to these places, and Frankfurt, Everton, Trondheim, Sydney, Boston. Here's Beirut, so we should have red here with blue coming afterwards. And in 2019, there's a lot of places that are on my diary already, many, many more than you see there. So I have a couple of slides because I've been prevailed upon over the years, or the months I should say, to put out some advice, and I was reluctant to do so, but here it is for what it's worth, and it is by no means an exhaustive list. To be successful in academia, you need to put teaching students before research as a principal investigator, to let students take ownership of their research, to put your students before yourself, to support your students through thick and thin, to identify a line of research that is receiving little attention, to recognize that progress in research will be slow, to be able to appreciate the significance of a discovery, to find out how to manage research, and to employ best practice in writing grants and scientific papers, and to set extremely high standards in presentations, both oral and written. And my three-liner is, you need good health. That is the strength of a horse. You need to take criticism without it biting you and demolishing you. You need the hide of an elephant. And you need, once you've made a major discovery, and you know you have, you need to push home your advantage. You need the work ethic of a honeybee. To be successful in life at whatever you do, treat people how you would expect to be treated yourself. Be respectful towards people younger than yourself. Treat people from different ethnic and cultural backgrounds the same. Think before you open your mouth. Realize that we live in a village. Don't speak ill of others. Be more ready to give than to receive. Be supportive towards those around you. Be ready, willing, and able to give praise. And work out how to turn bad things into good things. And no card impresario from the 1950s sums it up as the secret of success is the capacity to survive failure. Salesmanship is also important. Here's a quote from a Nobel Laureate in physics from 2011, now the president of Australian National University. And so I recommend that if you're not on Twitter, before you next visit the bathroom, open a Twitter account. So here I am, very quickly, amongst 25 that have been singled out. I don't know why there's nobody here from the American University here in Beirut. There should be 2 or 3 people, but I didn't draw up the list. And I've now been labeled, as many of you know, as the Twitter monster. And here is one of my nice colleagues that I enjoy interacting with on a daily basis, Omar Farah. We love our Twitter monster. Well, I love him too. And he's going to be one of your next Haddadine lecturers, a Palestinian. You have a great, I think, next lecture to look forward to. He's doing remarkable research at a great pace. Okay, so finally, this is the letter that came on the 5th of October after a phone call at 4 in the morning to tell me that I'd been selected, along with Jean-Pierre Sauvage and Ben Feringa, to receive the Nobel Prize in Chemistry for the design and synthesis of molecular machines. What was the response of Northwestern? Well, I won't go into it, but Northwestern had made my life, up until that phone call in 2016, absolute hell on earth. And I was on the point of leaving to go to Texas. There were times when I had 7 or 8 lawyers in my office. It was all for a very, very stupid thing that should never have got to the point it did. 3 people came one day and took away my email. It was just unbelievable, over the top. Anyway, they had to change their tune on this announcement. And how did they do it? Well, signage everywhere. I can't go through doors without seeing myself over the arch. We had a group photograph taken. Here you are with it over the technical building, which is the former and still home of the chemistry department. And of course, in next to no time, they provided this reserved parking spot, which is fine, but this was girst to the mill of my good friend Ben Feringa. You can't read this, but he has a parking spot for a bicycle. And so I'm a, gas-guzzling academic who drives a Maserati, which is not the case, of course, but he gets a lot of mileage out of this. And so I took him on, and I got in touch with the president at Northwestern, and I now have a bicycle parking spot. Only problem is I don't have a bicycle yet. I've not had time to go and buy one. But what I have shown on a visit to Tsinghua is that I can still ride a bicycle after many, many decades. And here's proof of it. Look at that. Nationally in the United States, the American Chemical Society went over the top. This is a 7 or 8 story building with Ben, myself, and Jean-Pierre being lauded. At the end of November, before you go to Stockholm, traditionally you get invited to the White House. There was no invitation to the laureates this year, by the way. Probably none of them would have gone, I would have thought. We managed to slip in when there was still a real president there, bless him. This is my elder daughter, Fiona, and younger daughter, Alison. And that was a memorable day. I gave him a copy of this book when I went in, The Nature of the Mechanical Bond. And he's quick as anything. He said, well, it looks as if I got some homework tonight. And then you eventually end up, 10th of December, receiving the medal and the certificate from the King of Sweden. All right, so I'm just going to end with a little bit of video of what the Swedish broadcasting system came up with on that evening. Before I do, though, there's the medal. There's one of my grandchildren holding it, Thomas. There's Harry, little Harry holding it. And William is not showing his face, but he's in the background there.
That was.
Oh, thank you, thank you.
Well, thank you.
Everyone and all the house. Oh my goodness. And we take this out. These youngsters will remember these few days for the rest of their lives, and they will, I think, probably go on with more self-esteem, more self-confidence, and will end up being more successful in their lives as a result.
Future Nobel Laureates.
Yes.
What about you kids? Did you have fun? Did you have fun tonight?
Oh yeah, this night was probably one of the best nights of my life.
It was? Really?
Yeah.
So what was the best thing about tonight?
Eating the chocolates.
Do you agree?
Yes.
What about you? What do you say?
I liked the singing.
The singing was really nice. Well, thank you so much for joining us, and have a wonderful rest of the evening.
Thank you, thank you. We can go and eat chocolate.
Thank you, Sir Fraser, for this very inspiring talk. Before we open the floor for questions, we have another commitment after here, but we promised that Sir Fraser is going to autograph the announcement. So we're going to open the floor for questions, but only let's have a couple of questions so that we get everybody to get the autograph. But before we do that, I would like to invite Dr. Haddadine to the podium. Dr. Haddadine will hand the poster announcement as a small token of appreciation to Sir Fraser. I invite all my team members right now that we take a group picture, and then we'll open the floor for questions. Thank you. The floor is open for questions now.
Yes, go ahead. Yeah.
Thank you for the very inspiring talk, Sir Fraser. I wanted to ask, how did you maintain your motivation and work ethic when you feel like you're being complacent or you've had a tough time with your colleagues? How do you refill your engine to keep on working, keep on producing, especially with your humble origins?
So I think it is just sheer determination. I was kind of shocked as the little boy coming from a farm and going through my Edinburgh education where I didn't meet any of this kind of we say, negativism in academia, and I didn't meet it in Canada either. The Canadian experience was a wonderful one, and so it was a big shock to the system when I came back to England in 1970, and I'm already then 28 years of age, and I find I'm in this hornet's nest of individuals who are at each other's throats. And the sad thing is, it has not changed to this day. I have an example in Italy of a brilliant Italian student who, postdoc, who returned 3 years ago, and I still got to answer an email of 2 or 3 weeks ago where he just describes how his colleagues are making life incredibly difficult for him, etc., etc. So it's still going on in the European system, and you know, I will talk and speak out against it with all the vigor I can. And as I say, I found it very difficult for these first 7 or 8 years in Sheffield, but my goodness, when I went back, I decided you undergo a change of personality. And the professor, who was the bane of my existence, on one day he called me into office and, you know, quite irrationally said, I want all your students out of these laboratories, I want the laboratories. And I said, well, where are they to go? He said, I don't care. So he said, come back in the afternoon and we'll see how you address the issue. And I went back in the afternoon, having done some homework over the lunch period, and he said, well, what was I going to do? And I said, Professor Ollis, if you continue with this attack on me, I will go and see the dean. And I said, if I don't get satisfaction there, I will go and see the registrar, which is the equivalent of the provost. And I said, if I don't get satisfaction there, I will go and see the vice chancellor. And I said, if I don't get satisfaction there, I will go and see the chancellor. And he looked completely deflated. He looked at me and he said, Dr. Stoddart, nobody has ever spoken to me like this in my life. And I had the courage to say, well, Professor Ollis, there had to be a first time. And at that point, I got up and I left his office by his own door into the corridor, and I slammed that door shut more than I had slammed any door shut in my life. It must have resonated around the whole building. And I walked along the corridor on air, and I asked myself, will this coward of a man come after me to do something? No. So I greatly wished after that confrontation that I had earlier on confronted the person that he was. Because I think if we all the time don't speak up against tyrants, and I extrapolate this to the world stage now, then we are in fear of almost terrible things happening to us. And I just would hope that the young people in America and in the UK would get on the streets and rebel against the level of leadership that they see in their countries at the moment.
So Fraser, thank you for the fascinating talk. Brief question about how you decided to fight against corruption as you saw it in your time in England. You mentioned writing to the Times and the Guardian, that sort of thing. My question is this: do you think that the environment nowadays would allow for that sort of protest and change as it did back in the day?
Well, back in England, I don't know that it would. It would depend on the subject, but the press seemed to be in the hands of the people who are in charge of bringing destruction to the country one way and another. And this is very, very worrying that a once, what you might have called mother of parliament, stable democracy is effectively being taken over by hoodlums. And they're very rich, and they use their money, obviously, to get the organizations, the press and so forth, to play according to their tune. I have to say the Guardian still speaks out against all this, and I actually contribute financially to the Guardian at the moment because it is so much a beacon in a very, very dark situation. It has been joined by the Independent, so there I think is a bit of hope there. So there would still be two newspapers I could write to. I don't tend to write to newspapers now because I'm an American citizen. In the UK, that is, I think it would backfire on me, but I am a little bit active on Twitter.
Another question, or shall we proceed with the sign? Question like that, please.
I'm interested in how you got the the big problem. Like, is it by research or experience or what, or reading or like?
Oh, I really identified the big problem by reading, by going to the library, which is not something perhaps that would be the way you would do it today, because the new scientific literature comes to you very readily over the internet. But I visited the chemistry department library at Queen's University in the middle of April of 1967 and saw this remarkable paper. And the fact that it turned out to be so remarkable was vindicated in the author receiving the Nobel Prize in Chemistry in 1987, Charles Pedersen. And so that, I would say, was my defining moment. I said, you're going to work on big rings, and everything else followed in a sort of incremental way from there.
Let's proceed with the signing, Sir Fraser.
Okay.
Please take your seat right there. First, Sir Fraser is going to autograph 2 copies of his book. One copy is the copy for the science library. So this is going to stay in the science library. The second copy is actually my copy. I bought that copy 2 years ago, but he had it pre-signed because at the time he was signing, I was giving a talk in the ACS meeting. And as soon as I arrived back to Beirut, I requested a copy for the science library. And I have had that copy in my office because I was planning for him to autograph it. Then we are going to proceed with the autographing of the poster. So if you can just line up right here, one after the other. If you don't have a copy, we have extra copies right here. And please feel free to take a selfie, to take a picture, tweet about it, tag Sir Fraser. He is gonna retweet every tweet he's tagged at. Trust me.
So why don't we sign that later when you...
روب هيك الكاميرا معانا ارجع قديش في ناس عم
Of his generation.